Hi, my name is Shri, and I'm part of AAC Science is Fun. Now, today we're going to be working with liquid nitrogen. And as you might know, liquid nitrogen is very cold. So it's important that we practice good lab safety techniques. And part of that is making sure we have safety glasses, and also that we're using protective safety gloves. Now, let's get started then. So, I have this big dewar full of liquid nitrogen. Now, this liquid nitrogen, like I mentioned earlier, is very cold. So what do you think will happen if I pour something that's very cold into this other container? It's not as cold as liquid nitrogen, so let's find out. There we go. What's happening right now? So I said liquid nitrogen is very cold, but it looks like it's bubbling. No, it's boiling. It's boiling right now. So why would liquid nitrogen, if I just said it's very cold, be boiling? Where would it be getting the energy to boil from? You're right, it's getting it from the dewar itself. This dewar is, because there's a difference in temperature, it's providing it energy to boil. The heat is going from the hot dewar, to the cold liquid nitrogen. Now it looks like it's starting to slow down and stop boiling. Why would that be? If there's an equal temperature difference, or something called thermal equilibrium, there wouldn't actually be any shift in energy. Now if I poured more liquid nitrogen in there, would it start boiling again? Would it stay the same? What do you think? Let's find out. Okay, so it started boiling again, but only at the top. It's not boiling at the bottom. Why would that be? You're right, there's only a difference in temperature at the top, so there's only boiling at the top. Now, there's a unique property about this dewar, is that there's an inner surface made of glass and an outer surface also made of glass, but there's a partial vacuum in between these two surfaces, and that helps hot things remain hot and cold things remain cold. Now, I also have this racquetball here. It's very bouncy, it's rubber, bounces very high. Trust me, it very bounces. And now, what do you think will happen if I put this warm racquetball into our liquid nitrogen? What do you think will happen to the racquetball itself? Let's find out. It's boiling again, right? Now, where is it getting the energy to boil this time? You're right, the liquid nitrogen is getting the energy to boil from the racquetball. The racquetball is so warm. Now, what do you think will happen if we keep it in there for a longer period of time? So, what about if we completely submerge it? What do you think will happen to the racquetball? Let's find out. Just gonna kind of push it in there. I think I'll just leave this in there and let it boil. But notice how the entire thing is boiling now as I push the racquetball down. So now I have another bowl right here, and let's use more liquid nitrogen. More is always better, right? So I'm gonna pour liquid nitrogen. Once again, what do you think will happen if I pour the liquid nitrogen into this bowl? Is the bowl at the same temperature as the liquid nitrogen? Definitely not. So it's going to start boiling. Now, heat is going from hot to cold. Heat always goes from hot to cold. So it's going from the bowl to the liquid nitrogen, from hot to cold. Now, it's once again boiling, all right? Let's wait for it to stop boiling for a moment. Let's wait for it to reach, what do we call that term again? When they're at the same temperature? That's right, thermal equilibrium. All right, so what do you think will happen once this reaches thermal equilibrium? What do you think will happen if I put a balloon in there? Do you think it'll pop? Maybe I'm not sure. Let's find out. So I'm going to put this balloon into the liquid nitrogen, and let's find out. Once again, there's a difference in temperature, so it's going to start boiling again. Is the balloon popping? Let's kind of push it in there, right? Hopefully we have enough liquid nitrogen in it. What's happening right now? It's not popping. What is it doing? It's shrinking. It looks like it's shrinking right now. Now, why would it be shrinking? It looks like it's getting all the way down. Now, why do you think this happened? It kind of looks like a potato chip now. Why do you think it looks like that? The cold liquid nitrogen kind of made it all small, right? What do you think will happen if I take it out? So I have these tongs that I'm going to use to take it out. It's hard to use them with gloves, but once again, it's important to be safe, so I'm going to keep them on anyway. So I'm going to try taking it out of there. What do you think will happen if I take them out? Do you think the balloon will pop? Do you think it'll go back? Do you think it'll explode? All right. It looks like it's expanding again, right? There's like frost coming off of it. It looks like there's something liquid inside of it. And the liquid's slowly leaving as the balloon gets bigger. What do you think that liquid was, though? That was liquid air inside. Crazy, right? So the air that we normally have around us is gaseous, but if it gets really, really, really cold, it can turn into a liquid, like what we saw inside the balloon. If you got to look at that. Now, there's this process is we called thermal contraction or thermal expansion. Thermal contraction or thermal expansion. When it was getting very, very small, we call that thermal contraction. It's contracting, it's becoming smaller. Now, when it was getting bigger, that was thermal expansion. And this process, once again, is actually pretty cool because this balloon is completely fine right now. Now, it also looks like our racquetball is done, like it looks like it's done, the entire thing is done boiling. So we're going to try taking it out of there. Kind of hard. It was a little rubbery before, right? I'm going to try pouring it in here. Did you hear that? That didn't sound like a racquetball. It sounded harder than a racquetball. Now, I have a question for you guys. Do you think it'll bounce higher or lower now that it's hard? Because, I don't know, golf balls bounce pretty high, right? So, do you think it'll bounce higher or lower? Make your predictions now. Alright, so, if you give me a countdown, 3, 2, 1. What happened? That didn't bounce at all. Now, these pieces broke into, it sounded like glass, right? When the racquetball dropped, but we know it's made out of rubber. Why do you think it sounded like glass? And there's like frost all over it. It's very hard right now. Like, I can't break this. Do you think it'll stay this way forever? Do you think it'll go back to rubber? What do you think will happen to it? Once again, make sure that none of you touch it, touch the pieces while it's still cold. And if anything comes near you, make sure you don't grab it until it's at least cooled down a little bit. Now, the edges are kind of warming up a little bit, as we can see right there. If you can see that, I'm not sure that you can, but one second, we'll wait for it to warm up a little bit more. But I want you guys to guess. Do you think this will be hard forever or be rubber? Okay. I'm gonna take off one glove for now, but still keep the other one on, because I want to show you that this edge right here is now malleable. Like, I can move it up, down, like it's not hard anymore right there. Do you see that? Now, the only reason I took off my glove, and I know that's very dangerous, but I still have my goggles and my gloves on, is because I think it's safe to touch now. Because look at the corners right there. It looks like it's back to rubber. Now, soon, this entire thing is going to go back to normal. You can see that there's some frost on there. There's normal parts where you can see it's rubber, and you can see the frosty part where it's still hard. Soon, like, everything will go back. You'll all get a chance to touch it at the end if you'd like to. All right, and there's one final thing I want to show you about liquid nitrogen. It's our grand finale, if you will. Of liquid nitrogen. Now for this grand finale, I want all of you to, well, we need some way to get rid of this liquid nitrogen. We can't take it back with us, right? So I want all of you to be very careful, but look at this real quick. So I'm going to drop the liquid nitrogen on the carpet. Let's see what happens. This is for science. I hope you had a really good time, and follow ASU Science is Fun on Twitter.